Hello, my amiable students. In this lesson, we will be dealing with effects of revolution of the Earth. We said earlier that Earth has two distinct movements, which are movement of the Earth and Earth movement. Earth movement is used to relate to orogenic evolutions as well as movement on the crustal plates like folding, which is orogenic, faulting, which is epeirogenic, volcanicity, as well as earthquakes. All these can also be referred to as tectonic processes. Movement of the Earth is the two distinct movements which the whole Earth engage in space and time. First, we have rotation, and second, we have revolution. So today we'll be talking about the effects of the revolution of the Earth. The first effect of revolution of the Earth is varying length of day and night, or changing length of day and night. Due to the Earth tilting on its axis to an angle of 23.5 degrees and the inclination of the Sun to the ecliptic plane, which is 66.5 degrees north and 66.5 degrees south, most places receive sunlight or sun rays and high solar energy throughout the year, which are places within the equatorial areas, because the limit of the Sun ends in Tropic of Cancer and Tropic of Capricorn, which is the only area where the Sun can be directly inclined to the surface, though in oblique rays. Because of this, when the Earth tends to be facing the Sun directly, or when the apparent movement of the Sun has its ray directly on the Earth's surface at the equator in March and September, the whole of the Earth receives equal light hours and equal dark hours, or hours of darkness and hours of daylight. This we refer to as equinox. So in September 21 and March 22nd or 23rd, the whole of the Earth enjoys equal hours of darkness and equal hours of daylight. But after a while, the apparent movement of the Sun tends to swing to the Tropic of Cancer in June, making the Earth to have imbalance in light hours and hours of darkness. Because the Tropic of Cancer is in the northern hemisphere, the whole of the northern hemisphere enjoy more light hours than darkness. Within the equator, light steadily increases till we get to the Arctic Circle, or the North Poles, where the Sun never sets. Then, in the south, around the equator, the hours of darkness also steadily increases till we get to the Antarctic Circle, or South Poles, where the Sun never rises. So the Arctic Circle and the Antarctic Circle and places within them where the Sun never rises or the Sun never sets are referred to as the land of midday darkness and the land of midnight sun. Examples of places are Greenland, Iceland, and Oslo in Norway. This is termed solstice. So solstice are normally during June, which is northern hemisphere's summer, and December, which is northern hemisphere's winter. But when the northern hemisphere is enjoying summer, the southern hemisphere will be enjoying winter because the light is in the northern hemisphere. Then when the northern hemisphere is enjoying winter because the light is in the southern hemisphere, the southern hemisphere will be enjoying summer. So this takes us to the second effect, which is referred to as changes of varying altitude of the midday or afternoon sun. Inclination or the solar radiation on the surface tend to change in their angles as the Earth rotates, either due to the ecliptic plane or the tilting on its axis, which does not enable the sun rays to get to everywhere on the Earth's surface at the same time in the same form. So when the Earth tends to northern hemisphere to face the sun rays, then southern hemisphere, like the 66.5 degrees to 90 degrees, will receive no sunlight, while 66.5 degrees to the equator in the southern hemisphere will receive light in oblique ray form. But when it is in the Tropic of Cancer and in the Tropic of Capricorn, then the level of sun rays will still be oblique. Only when it is in the equator that the equatorial area will receive ray of light in vertical form. But the equatorial areas as well as the tropical areas always receive light forms that are nearly vertical or slightly vertical, ranging from 90 to 98.87 degrees, making the sun to be intense in certain times of the year. The sun is always intense in the northern hemisphere during summer, and at this time the sun tends to be vertical or overhead at the equator. The rays of light in ecliptic plane to the polar regions, which is the Arctic Circle and the Antarctic Circle, are always oblique, making the sun to be negligent, especially in the Arctic region and Antarctic region, making these places to always be in ice caps and low surface temperature that makes precipitation to be in snow, frost, or other forms apart from rain. The third effect is seasons. Within the ecliptic plane, which is 66.5 degrees to the polar region in 90 degrees north and south of the equator, places enjoy 4 seasons that are well marked and distinct from one another, though not very demarcated and distinct within the tropics and the equator. So these 4 distinct seasons that are witnessed or experienced within temperate region, Arctic circles, are 1. Summer, which is a time when the sun is in a particular hemisphere. Such hemisphere experience summer because it is sunny and the surface is heated and lighted in good proportion, making the place to be windy. Then, when such hemisphere has no light or rays of the sun, as the sun has swung to the other hemisphere in its apparent movement. Such hemispheres tend to be very cold, dark, and not well lighted. But instead of being windy, it is now breezy. So such hemisphere is said to be in winter, especially from the limit of the ecliptic plane to the North Poles. When this apparent movement of the sun is leaving winter and coming to summer, or when it is coming to the other hemisphere, such place is said to be in spring, as the ice or frost tend to thaw, making the whole of such hemisphere to be colder and darker in form. So with this, surface temperature tend to be very low, while precipitation in the ecliptic plane towards the circles are normally marked with snow, as well as frost conditions or blizzards